Welcome, everybody. It's a true honor to be here, and it's got a lot of significance for me that this is actually happening here at UNCA and Asheville. This happens to be my alma mater, where I graduated almost 20 years ago. And it was here, actually, that I first learned about Black Mountain College and even Buckminster Fuller, in no small part thanks to Connie Bostic and her kind of deviant influence on me at the time. And, you know, a lot of the professors here I found that it being a liberal arts university were very encouraging of some of the more exotic ideas that I had at the time, which even in this type of environment where it was encouraged really to kind of transcend disciplinary boundaries and inquire in different ways, they were very supportive, and this was actually the only other place where I'm not really a president type, so this whole thing of me being the president of BFI I don't really know what that means, but I did it one time at the school here with a student organization, which tried to provoke as many people as possible into some type of epiphany that we all need to be provoked. And so I think that's what draws me to Buckminster Fuller, is that he provoked the hell out of the world. And he still is. And it's a critical thing that we recognize what those provocations were, and we look at his life and work in the context of the era in which he was operating. And so that's a bit of what I'd like to talk about tonight. And really, you know, just to cut to the chase, because he would encourage us whenever we're trying to talk about problems and things, just to start with universe, as he would say. So, you know, I kind of like to pose the basic question, you know, like, why are we here? And I don't just mean here tonight, I mean, like, from the perspective of cosmic evolution of 200,000 years of human history, of 13.7 billion years of the history of the universe, why are all of us here and self-conscious and dealing with the paradoxes of being human at this particular point in history? And on the left of this is one of the earliest human figures, a Venus figure from La Salle, France, which I happened to do my DNA tests recently, and I found out that my fraternal bloodline actually dates back to this place in France where these figurines were being made. And on the right is an image from the Pioneer 10 plaque that was put on a satellite in 1972, the year that I was born. And that satellite is somewhere around 10 billion miles away from Earth. It's been traveling for 40 years now at incredible speeds. You know, and I think that the fact that as humans we've been able to kind of accomplish this range of things over these incredible periods of time, because the Lascaux figurine is about 25,000 years old, speaks to our inquisitiveness and the inquiry that we have. And not many people are bold enough to really assert why we're here. And of course, Fuller had an answer for that, which is typically succinct. And it goes something like this. He had this working assumption that we are here as local universe information gatherers, and that we are given access to the divine design principles so that we can therefrom objectively invent instruments and tools, e.g. the microscope and telescope, with which to extend all sensorial inquiring regarding the rest of the to the naked eye invisible micro-macro universe, because human beings, tiny though they are here for all the local universe information harvesting and cosmic principle discovering, objective tool inventing, and local universe controlling as local universe problem solvers in support of the integrity of eternally regenerative universe. Right? That actually makes a lot of sense. I mean, I hear people talk about Bucky's impenetrability, and when I read this, I was like, well, yeah, actually, that's the thing. Except I've come to slightly disagree with it. I've come to think that it's kind of an incomplete answer. Maybe he needed some footnotes on this, some addenda. Because the idea of us being local universe problem solvers might be a little bit too simple. I'm probably one of the few people that would dare to ever accuse Bucky of being too simple. But, you know, I think that one of the things that we've discovered in the past few decades in particular is the nature of complexity. You know, and what if, in the face of everything we're facing, we can't actually solve some problems? Right? What if it's not so simple that we just have, these amazing technological devices that are going to fix things, or that we have some particular approach, or we have some scientific insight? What do we do? How do we address this stuff? And it seems like every day we're finding out more and more about the complex nature and the interconnected nature of these problems that we face, right? This is a visualization from the World Economic Forum last year in an attempt to visualize all of these interconnected, what they call global risk landscape, and you can you see that okay? I can't see it. But it's basically, what do we got? Information infrastructure breakdown, weapons of destruction, food security, geopolitical conflict, global governance failure, hello, economic disparity, extreme energy price volatility, regulatory failures, not to mention all of the planetary boundaries that we're facing of biodiversity loss, climate change, ocean acidification, land use change. We're facing some hella problems, as the colloquialism goes, and we need new ways of talking and thinking about these things so that we're not trying to find some overly simple, starry-eyed approaches. And because of this complexity, I'd like to propose that these problems aren't necessarily solvable in any traditional sense. That instead, it's been suggested that we can kind of frame these not as tame problems, but as wicked problems, right? That they have immense consequences for whatever we do. And there's no absolute solutions or right or wrong answer. There's just really better or worse possibilities for dealing with the consequences. And even those adaptations and adjustments require profound changes in how society and all of us individually behave. And most of the time, of course, all of these symptoms are just deeper problems that have arisen from outdated assumptions. Right? And Fuller was actually fond of saying, don't try to define the solution, define the problem. And I think that's more critical than ever, because we're having a very difficult time with a bunch of the assumptions that are coming out of the past few centuries, particularly within Western science and Western thought, and how we think about the distinction between humans and nature and externalization and the entire foundation of neoclassical capitalism and everything that Bucky wrote about in Grunch of Giants that we're seeing manifest all over the world right now, that it's critically important that we get to some of the foundational assumptions that we're making about the nature of reality. And that these wicked problems in many ways are kind of the proverbial elephant in the room, the intractability of them, and being able to accept and address and face up to what that means. And it's worth recalling this parable of the blind men and the elephant, right? This originally came from Jainism, but it's been adopted all over the place. And these were originally monks. And as each monk felt a different part of the animal, they seemed to describe something completely different. One was touching its leg, thought it seemed like a pillar. One was touching its tail, thought it was a rope. Another was kind of rubbing the tusk and thought it was a pipe. And similarly, we've all been trained to see through the lenses of our specialized disciplines. Right? And it's difficult to come to an agreement on, forget the solutions. I mean, what we're even talking about most of the time, because everybody's going to see the problem through the lens of however they've been entrained. And not only that, we have an extremely difficult time even with the vocabulary. So even if we're trained in the same way, we're going to be in kind of subgenres of some discipline that we can't even communicate across those disciplines. And here's a very interesting visualization. And it's estimated that we currently have over 8,000 academic disciplines, 50,000 journals, and over 1 million articles published every year, right? And this is a visualization from the Web of Science and Scopus to kind of academic databases that used over 7.2 million papers from 16,000 separate journals, proceedings, and series that covered 554 of those 8,000 disciplines, right? And the nodes represent clusters of journals that are color-coded by field and size-coded by the number of papers they contain. All right, and the cross-link structures, kind of the struts that you see, are the links between disciplines in the papers. Now, what I found particularly interesting about this, and particularly since we're at UNCA, which is kind of North Carolina's premier liberal arts university, is look at humanities up in the upper left-hand corner, the yellow. Right? It's probably appropriate that it's yellow because it's the one that's about to disappear on the map. And there is no significant correlation between biology and the humanities, or chemistry and the humanities. or geology and the humanities. And to me, this is extremely problematic. This is a divide that many years ago was labeled the two cultures divide between the sciences and humanities. And one of the things that I think is one of the most profound aspects of Fuller's legacy is that he naturally inhabited a space that bridged this divide in profound ways. And not only did he bridge the divide, he didn't even recognize the boundaries between any of these disciplines, right? And he operated in such a way that he wanted to demonstrate what it would look like if we were to really go about addressing challenges in what he called comprehensive and anticipatory ways. He was pretty explicit about this. He said, "We're in an age that assumes the narrowing trends of specialization to be logical, natural, and desirable. In the meantime, humanity has been deprived of comprehensive understanding. Specialization has bred feelings of isolation, futility, and confusion in individuals. It's also resulted in the individuals leaving responsibility for thinking and social action to others." Now, if this doesn't resonate more profoundly than ever before with regards to the type of media landscape and environment and kind of political mania taking up all of our excess cognitive bandwidth today, I can't think of a time in history where this level of specialization and particularly distraction has really detracted from our capacity to think in terms of the big picture and to think about all of these interconnections. And I just watched Mary Emma's lovely talk about the construction of the supine dome. And I was thinking how this is a very good metaphor for kind of how we need to approach these things. So probably most of you are familiar with this project when Bucky came to Black Mountain in 1948, and he worked with students, and they were kind of working on this early prototype of his first geodesic dome. And they didn't quite get the right materials, and they had these aluminum struts, and of course the whole thing kind of was a spectacular, wonderful learning event that we would sometimes call a failure, but you can never learn less, as he would say. But he came back a year later, he went to Chicago, he did a few refinements, worked with another project, another team, came back with stronger struts, worked with the students to actually construct this other dome, right, that actually stood with the struts and the hubs all synergizing together in such a way that it created this incredible structure. And whenever I look at a dome, I can't help but think about all of those nodes from the disciplines or from different areas and how these interconnections are absolutely critical, because you take one of these away and the entire thing can collapse. And I think this is precisely what's happened in academia. I mean, when you think about the amount of money that's spent on research and sort of what we're getting in terms of what the questions we're asking, right? Why are we here? What are we doing? What are we trying to find out? What are we trying to accomplish? What's our intention? And I think the challenge with this question, and Bucky realized this pretty early on, is that we might not be evolutionarily prepared to ask it. Given the acceleration of our technologies, of our knowledge, of planetization, which I like more than the idea of globalization, because we have a cognizance of this being a planet in the cosmos now, which really started about 500 years ago, but it's been accelerating rapidly. And in my experience, we need better tools to help people to think in terms of these big pictures, that our old modalities of communication just simply aren't working in the way that they should. And Fuller started thinking about this, a long time ago. This was 1927, an illustration that he did, and he was kind of working out the number of houses that would be necessary over the coming decades, and people returning from World War II, and what the shelter requirements were going to be, and thinking in terms of human need, right? Not just like doing something because it's interesting. He's doing something because it's necessary, right? And looking at what the matters of concern would be facing humanity. And through this, he started working on a number of ideas about how to make these things visible, to understand these trends in such a way people could start to see the interconnections. And he really wanted, he wanted to go straight to the top, of course, which is kind of his primary strategy, and to help individuals, communities, and world leaders find new ways to realize kind of regenerative approaches instead of the extractive mentality that had been dominating economics for so long. This is a 1956 drawing of his mini-Earth display he proposed to put outside the United Nations as a reminder to the delegates that we share one planet. And of course, famously, the whole Earth image that is so famous from Earthrise in 1968 was only about a quarter sliver of the planet, and it's one little tiny part of the electromagnetic spectrum. So he was trying to map out different ways of cartographically representing land masses so we could see things in undistorted ways and see Earth as one Earth island and one Earth ocean. And he was tracking things rigorously for many, many decades. This is a map of transportation and communication and the shrinking of the world, to really demonstrate the extent to which there is what he called this, accelerating acceleration. This came out the same year that Gordon Moore proposed the famous Moore's law about computing power. So Fuller was thinking along these other axes and using this extensive archive he'd been developing for decades to kind of keep track of all of this. And from that, he worked with a number of students to develop really the first comprehensive inventory of what they called world resources, human trends, and needs. So instead of organizing knowledge by disciplines, looking at the domains of human need, and they attempted to define what the students called, and I love this term, bare maximums, right? Not bare minimums, but bare maximums of food, water, energy, housing, transportation, and all of the other areas necessary to enable everyone on the planet to realize their full potential. And of course, they eventually brought this together within the ideas of this concept they called the world game, intended to help players understand the planet through the lens of all of this data, of as objective as possible, looking at the advantages that science was giving us to be able to start thinking more synergistically so that the world could work for everyone. And he worked with teams to prototype how to talk about this stuff. This was some of the tools they were developing. So this is a 1970 map of bread grain distribution around the world. Another map of energy consumption, or what he would call energy slaves. And he had this kind of grandiose visions of doing a world resources simulation center where world leaders could see an overview of these global metabolic flows and phenomena. They'd stand above this huge map and get a sense of the illusion, the sense of the illusion of separateness is really forced on us by these imaginary political boundaries. And the ideal was to realize this in such a way that they could kind of pull up any of the data at any given time to be able to correlate and extract narrative from all of that. And through his calculations, he determined that by 1972, the year Pioneer 10 was launched to send images of humans 10 billion miles out into space, he determined that because of the ever-increasing technological ability to do more with less, that for the first time in history, it was possible to take care of everybody at a higher standard of living than anyone has ever known. That all humanity had the option to become enduringly successful. Now, the thing that's important, I think, to realize about this is a lot of people can kind of claim this, and this is actually, I've seen this a lot within kind of techno-utopianism lately, where people are just, they want to put all of our faith in technology, we don't really have to worry about it, things are getting better. But the thing I most deeply appreciate about Fuller's life's work is that he wasn't Pollyanna-ish about this. There were extreme caveats that he wasn't just blindly saying it's all going to be okay. He was suggesting that it's actually up to the integrity of every single one of us to try to realize what it is we're doing here and to act on that. And, he didn't put it in much more blunt terms than in the title of his 1972 book, Utopia or Oblivion. And I find myself often kind of reflecting on this. I was born into this world where here's this guy who'd been going through this, crazy process of learning all of this stuff for, well over 50 years at that time. And we're all born into this world to deal with this complexity. So for the past 15 years or so, I've been really exploring, the potential and the applications of some of these proposals that he was putting together. This is a demonstration of a project I've been working on for the past 6 years or so. It's called the Geodome, and it was really inspired by Bucky's idea of what he called the geoscope, to visualize global phenomena and to be able to use scientific data to visualize things in a cosmic context. And so we use models of the universe and take this around the world, and we have them in numerous places, to try to get people outside of the kind of myopic framing the de-geniusing that occurs. Like, let's remind them of their cosmic connections and the fact that we are truly the universe becoming aware of itself. We're doing very similar things with digital globes. This is much more along the lines of the original geoscope vision. But there's an incredible amount of data around that we can be utilizing to really look at the planet as a whole. And part of what I've realized is that as profound and interesting as some of these visualizations are, that they themselves don't actually do much. That a lot of times they can actually intimidate people because all it does is make the complexity, after you kind of get past the epiphany and the kind of awe and perhaps even falling in love with the planet in a new way and starting to understand our cosmic place, that then you get to the really tough questions. Okay, what do I do tomorrow when I wake up? Right? And I went through this myself. I mean, I in good conscience couldn't go out anymore and try to encourage people to sort of, wake up without having something else that could help to maybe shine a light on what possibilities are. And so that's when I really started turning to some of Fuller's work. And this is a model from, not actually from us, but from the International Futures Forum, but I think it beautifully illustrates kind of some of these interconnections in these nodes, that by looking at the domains of knowledge through the lens of human needs, that we can start to actually ask some really relevant questions concerning why we're here. And we can start to understand these interconnections between all of these different areas, because none of them exist in isolation. And what we're finding out is that they're all so deeply interconnected that unless we're willing and able to take more comprehensive approaches, that we're just going to keep creating more and more wicked problems, because there are all of these unintended consequences of trying to address any of them in isolation. And this has really been the project of the past 5 years of the Buckminster Fuller Institute, where we've started this challenge program called the Buckminster Fuller Challenge, where we simply put out a call to the world looking for designs that have the significant potential. And Kirk and I were discussing whether this is a mantra or whether it's poetry, so I'll try to say it as both. But make the world work for 100% of humanity in the shortest possible time through spontaneous cooperation without ecological offense or the disadvantage of anyone. This might be very familiar to some of you. It might be alien to others, but a lot of times we say this and people laugh. Because when you set the bar this high of human expectations, we're so used to being disappointed by, our expectations and projections of other people being stupid or, failures or whatever, the kind of messages come across, that it's very difficult for people to even wrap their head around the fact that this is even possible. Like, this is just kind of this silly, utopian notion. So we decided to have this challenge competition to give away $100,000 a year and see what comes back, right? I mean, just kind of get in the world and do it. And we asked people's permission to publish these projects online. They're on a site called ideaindex.org, and you can go online and check them out. And we've gotten some recognition in the past 5 years through this experiment. And for me, it's been absolutely transformative in the way that I understand everything in the world. And the people that I've met through this project are absolutely the most incredible human beings, like way beyond any kind of level of comprehensive thinking I thought that I could ever meet. Some of them are completely intimidating, not because of ego or anything else, but just their depth of compassion and their depth of love and their ability to think across scales in profound ways. And so we're putting all of these up, and I encourage you to go online and check these out. A lot of them are on exhibit at the Black Mountain College Museum, where we're having the reception a little bit later. But I wanted to just review very quickly how it is that we've distilled the complexity of Fuller's vision of what he called comprehensive anticipatory design science, which even the name of what it is too much for some people. So how do you distill that to something that's actually meaningful? How do you actually decide what could make the world work for 100% of humanity? So the first condition is really to optimize conditions from inception in order to create the most desirable, sustainable future conditions. That's really defining the preferred state. This is a project called Dreaming New Mexico. The image there that was a runner-up a few years ago that facilitates ecological and social restoration at the state level by reconciling human organization with natural systems and energy and food systems. They use all kinds of interesting mapping tools. It's got to be comprehensive to apply a whole systems approach to all facets of the design and development process. This is a project called the Polydome, which is a greenhouse design that works symbiotically with plants and animals and fungus to maximize food output and minimize environmental impact. And they create jobs and all of these other side effects that are anticipated. It needs to be anticipatory, factoring crucial future trends and needs, as well as projected impacts of implementation in the short and long term. This is Plant Chicago, which emerged from some attempts to discover new ways of integrating sustainable agriculture and manufacturing in disused industrial structures in Chicago. And so it closes energy and waste loops in the built environment, and it directs the waste output into processes that are beneficial. Similarly, ecologically responsible, this is a greenhouse project called Watergy that allows 85% recycling of irrigation water. 85%, I mean, it's unprecedented, and accumulates CO2 internally to create higher rates of photosynthesis for plants, which they do in the middle of the desert. It's got to be feasible, relying on current know-how, technology, and existing resources. This project, The Future of Fish, was a runner-up this year that looked at the supply chain of fisheries. A woman named Cheryl Dahl went through some ungodly number, like a couple of thousand projects in the Ashoka database to understand the supply chain and the disconnect between when you buy your fish and where it was plucked out of the ocean. And she's increasing the coherence and the integrity of that supply chain, and it's absolutely a mind-blowing comprehensive view of how industrial structures and supply chains can be set up. It's got to be verifiable to withstand rigorous testing. This is a project in the Congo Basin, working with local tribes that most of the world calls, are known as the Pygmies, but they've been there for many, many, many tens of thousands of years, and they're using cutting-edge GIS technologies so that they can map their territories and use them as negotiation tools to secure land rights. It's got to be replicable to adapt and scale to a broad range of conditions. This is a project called the Global Village Construction Set, a brilliant project called Open Source Ecology that is developing an advanced industrial, it's kind of an economy in a box, they call it, to be replicated inexpensively anywhere in the world, kind of the 50 machines you would need to bootstrap society. And with all of these, perhaps the most important aspect that we're looking for and we're trying to understand, because Bucky called for this consistently, are trim tabs. And this was the notion that was so important to him that out of the possibly millions of words that he wrote over the course of his lifetime, or at least accumulated in the chronophile, that he decided to distill this down and place it on his tombstone of call me trim tab. And the idea here is to demonstrate how relatively small amounts of leverage, energy, and resources can be strategically applied at the right time and place to produce maximum advantageous change, right? And a trim tab is not a diet pill. It's a little tiny rudder on a boat or a plane that basically controls the big rudder. Any of you sailors out there, you're intimately familiar with this and the power of what this does, because it essentially means that instead of trying to get to the side of the Titanic with an oar and row like hell to try to change the trajectory of this huge ship, understand the system. Understand where you get to that small rudder so you can apply the least amount of pressure to get the maximum amount of change. Very simple design philosophy, unfortunately not one that we're taught very often in the current education system. And I think this is really distilling the essence of what Bucky was trying to demonstrate throughout his life. And so if we just look very quickly at a few of the winners from the past few years, this is a project by John Todd, biologist. It was called Comprehensive Design for a Carbon Neutral World, the Challenge of Appalachia. And so for decades, John Todd, who actually worked with Fuller, has been developing these machines and techniques for extracting toxins from water in what he calls living machines. And he has this extraordinary, detailed, comprehensive strategy for restoring the landscape of West Virginia that's been devastated by decades of mountaintop removal, something that's near and dear to those of us that live here in southern Appalachia, with all of this power being driven by mountains being burned about 5 miles from here that have been extracted from other communities in West Virginia, right? We're the number 1 or number 2 user of mountaintop removal coal in the country in North Carolina. But the key to this, the trim tab, in a real sense, is understanding the metabolism of microorganisms, right? That because of Todd's deep understanding of biology, he developed these techniques to understand how to use the four kingdoms of biology in such a way that he could use natural processes to extract toxins. And for decades, he's been doing this. And this is, I think, at the Omega Institute in New York. And he has these machines all over the place that are actively functioning to understand how it is that we can create, instead of sort of big industrial machines for removing toxins, working with the forces of nature. And he starts off with this, in the case of the proposal for Appalachia, he starts off with coal slurry, detoxification, where the eco-machines will detoxify literally trillions of gallons of the slurry, because there are these giant lakes of slurry, and create environmental benefits simply by cleaning the water. But then he integrates all of these other techniques for rebuilding the soils, both ancient and modern techniques, and then he extends that to renewable energy projects as well as shared ownership for the people that live there. It's extremely comprehensive, and it's one of the things that I would really, this was our first year's winner, I really want to see this happen, and it's something that I think that we need to increasingly let the world know about. This is an example of an eco-machine in action in China, a city of 6 million people that was emptying their commercial wastewater, and these canals that run throughout the cities. I mean, the before and after shot pretty much says it all. The 2009 winner was a group from MIT, where they've developed this transportation system, an incredible, what they call a green wheel, that's a battery and a motor in a wheel. You can just put it on the back of any 26-inch bicycle hub, the scooter that's got like 120 working parts, these cars that are these kind of amazing little robo sci-fi things that do this one-point turn and you get out the crazy sci-fi stuff, right? But the reason this was so profound was because they understood the nature of networks, right? They were looking at networks and how they were centralized, distributed, and decentralized, and they started to connect from a systemic view what it was that the transportation needs are within cities. So they had these ideas of how to use this incredibly expensive space that we call parking lots, or not parking lots, parking spaces in cities, so that they could put solar panels and windmills and things on the top of existing buildings and then charge through induction these cars. And happy to report that the car is now actually in production in Spain. And these are some of the team members, and so this has been getting a lot of coverage lately. It's pretty amazing. Operation Hope, permanent water and food security for Africa's millions. This is a process called holistic management developed by a guy named Alan Savory that's really designed to address the root causes of environmental degradation, which he claims are really how humans make decisions that produce the results of that degradation. Trim tab, understanding this. Right? Or more precisely, understanding this and how it interacts with all the stuff around it, right? Because if you understand livestock and the evolutionary relationship between livestock and grasslands, you start to get that when there were millions of livestock in some of these places, the grasslands were much healthier. It's just that we confine them, and the techniques that we use for management are actually deteriorating. That's completely counterintuitive to everything that we think we know about livestock and CO2, because we hear about it from the context of factory farms in Brazil and everything else, but he's discovering that by looking at maps of grasslands around the world, that in the calculations that they're running, and here are some roots of grasslands that create what's called soil organic matter, that if we can have a 1% increase in soil organic matter around the planet, that would essentially sequester and decrease atmospheric carbon by 67 parts per million. Now, for those of you familiar with CO2 numbers, and we're almost at 400, we got to get down to 350. This is actually a viable way to do that. And since they've won this challenge, and by the way, more before and after shots, this is after I think 2 or 3 years in Africa, they're rapidly regrowing grasslands, they're increasing water sequestration, they're providing jobs for people in Zimbabwe, and actually they've got millions of acres under management all over the world. And at this point, they've successfully raised tens of millions of dollars to implement this all over the world. It's an extraordinary project. 2011, a guy named Al Harris, a biologist, marine biologist, who went to Madagascar, noticed that the communities were devastatingly poor. They were overfishing. Their ecosystems, their ocean ecosystems along the west coast of Madagascar, were being devastated through overfishing. The key to this is octopus sex. That he understood the reproductive cycles and the needs of octopus so that they could regenerate And he started to understand that if they would stop fishing for octopus for just a few months, and they would do something else, but just a few months, this was their primary cash crop, that they would rebound in profound ways. And so he moved there, he started up an ecotourism business, he became friends with the community, he embedded himself within there, and he finally convinced one community to do this. And it was so successful, they increased their yield, they increased their profits, they could start afford family planning, they could start affording education, and now something like 100 communities have adopted this voluntarily on the coast of Madagascar, and it's now the largest community-protected marine preserve in the Indian Ocean. And before we gave him our prize, he'd never gotten any money from anybody, right? And there are these stories all over the world. I mean, the people are doing extraordinary things, but we need to build this community of practice so that people can see the types of examples of what people can actually do. And it's not claiming to solve anything necessarily. They're tackling these wicked problems in profoundly comprehensive ways. This year's project, I'm not going to really say anything about it because Jason's coming up. And I couldn't really say enough about it, and I'm glad that he's got some time to talk about it, because I think that honestly, kind of what this reminds me of, and I'm really glad kind of at this historic 5-year mark, when I think of this project, it reminds me of the kind of famous William Blake quote that the world can be found in a grain of sand and heaven in a wild flower, right? And in many ways, the Living Building Challenge demonstrates what Bucky intuited all along, that the ultimate trim tab is the brilliance within the design of the regenerative cycles all around us. Right? And the Living Building Challenge challenges us to take on the personal responsibility of living within the integrity of these cycles. And as you'll see over the course of this weekend, Bucky really devoted his life to identifying these cosmic, what he would call patternings, in order to understanding the keys to evolutionary success. And so every time, I hope, like me, every time you see a geodesic dome, you'll think he's much more than that dome guy. He's actually, these are demonstrations of his attempts to discern the fundamental principles operating in the universe. And through his attempts to try to understand this structurally and to understand the nature of synergies, to get us away from the exclusively reductionist view, and to start understanding the nature of what syntropic forces look like, that we can begin to participate much more actively and consciously within the design of our environments. Now, of course, most of you know about Buckminster fullerenes, that were formulated and then discovered years after his death, and is now the foundation of nanotechnology, carbon-60, which have recently been found in spades in outer space coming out of a supernova explosion, the volume of about 10,000 Mount Everests. I can't think of a more interesting philosophical proof, right? If you have any questions about how philosophers are doing, just look to the skies and see who predicted what we're going to be seeing. And ultimately, I think the most interesting thing about Bucky is that by pointing to principles, he was suggesting that there are no panaceas. There is no one-size-fits-all. There is no ultimate fix-it. That even though he's called us universe problem solvers, I think he truly grappled with the complexity, and he truly understood what this was all about. And he really encouraged us that if we want to change something, we can't fight the existing reality. We have to build new models to make the old ones obsolete. And that's what we're trying to do at BFI through building this community of practice. I really appreciate everyone coming out to participate in this discussion. I think it couldn't be more timely to connect the legacy of all the work that he did with all of the people that are here. And I want to thank Alice and the Black Mountain College Museum and Art Center for curating this and inviting all of you to talk about your work, because all of this is just a platform from which we can share our experiences so that we can help humanity understand these eternally regenerative principles. And lately I've kind of adopted this particular slogan that I think summarizes the metaphoric symbolism that can be found within the tensegrity strength of these geodesic structures from which we can all hang. Thank you.